I'm Anil Kumar. Welcome to my series on quadratic functions. We'll begin with the properties of quadratic functions. I have 4 related questions, and this will be followed by a worksheet and some test papers. So once you have understood the basic concepts, I'd like you to attempt questions from the worksheet and then try the test paper on this topic. You can actually pause the video, copy these questions, try them out. I hope you can see the first 3. Let me push this page a bit so that you can see question number 4 also. Now, we are going to take these questions one by one and solve them. The very first question here is justify that the data given below represents points on a parabola. So we are given x and y values. And then part B is use 2 different methods to find the equation to represent this parabola. Now, quadratic function, whenever you graph, it will be shown as a parabola, right? So that means you have to show that this is a quadratic function, right? Where the degree of the polynomial is 2. The method to show is finite difference, right? So well-known method. So we'll actually do finite difference method. And if the second difference is finite, constant, if second finite difference is constant, then it is a quadratic function and it will be graphed as a parabola. Clear? So let's find the difference between consecutive terms. You see that these are in the interval of 1. X values are increasing by 1. That is important to note. They should be increasing by the same amount, otherwise you will find the difference, right? So we can only find the difference between the y values and then work on it, since the x values are changing only by 1. So let's first find the first difference. So let me write first difference as this. So when you do 9 take away 19, you get minus 10, right? 3 take away 9 is minus 6, 1 take away 3 is minus 2, 3 take away 1 is 2, and 9 take away 3 is 6. So definitely it is not linear, right? Now let's find the second difference. So difference between these two. So now we'll find the second difference. I'll just squeeze in this limited space. So if I do minus 6 minus 10, we get 4. Minus 2 minus 4 is also 4. 2 minus minus 2 is 4. 6 minus 2 is also 4. So we see that the second finite difference is 4, which is constant, and therefore it represents a curve which will be a parabola, right? So we can write here that the second finite difference is constant. You can say equal to 4, right? Therefore, data represents a curve parabola. Perfect. Now part B is use 2 different methods to find the equation to represent this parabola. Now there are 3 actually popular ways to do it. So let me list 3 methods here, and then we can do any 2 of them, or we could do all 3 of them. You can choose which works best for you. One is that whenever data is given, we could write this in the vertex form. We can write this in standard form, or we could write this in factored form. Now these are standard ways. However, from this particular data, you know the y value is not 0 and it is not going to be 0. So in this particular case, factored form is not your choice. Now here, there are no x-intercepts. Let me write down a note here. We do not have no x-intercepts. So, excluded. Correct. So basically, most of you are left with these two forms in which you could provide the equation of this parabola. But here is also another form which we say partial factored form. We could use partial factor form in all the cases. So, partial factored form somehow is not treated as a standard form, right? So, most of the time in many of the schools, you may avoid that partial factored form, right? Okay. So, what I will do here is I will show you two methods. We'll do vertex form. Now, vertex form here, since this particular data shows you a value of y which is minimum and there is a symmetry, right? So, from here you could see that we have minimum at 1, 1, right? And it is symmetric, right? It is increasing by 3 and 3 and then 9 and 9. So, as you can see, the parabola, if you try to sketch this graph, it will look like what? Let me sketch. To give you an idea, I'll sketch it right here in the center. Since it is always positive and it has a minimum at 1, 1, so it could be sketched kind of like this. Okay, so that is a rough sketch. The point here is 1 and this is 1, okay? So, and then at 0, we have a value which is 3, right? So this is definitely not to the scale, but you can see it is 3, and then here also it should be 3, correct? So this 3 is at 2. So that is the kind of parabola for which the data is given to you. Now, clearly, from this particular situation, we know the vertex, right? So what I will do here is I will write vertex form here. It's very easy to find the vertex form of this parabola. So we have vertex at 1, 1. As you can see, it is the minimum and the parabola opens upwards, clear from the data itself. So I could write this equation as y equals to a times x minus 1 whole square plus 1. Since the vertex is at 1, 1, right? Vertex is at 1, 1. To find the value of a, I could use another point which is 0, 3, right? So what we have done here for vertex form, we know from the data that one point is 1, 1, which is the vertex, and the other point which we are going to use is 0, 3. To find the value of a, so if I substitute 0 for x and 3 for y, we get 3 equals to a times 0 minus 1 whole square plus 1. Bringing this 1 to this side, we get 3 minus 1 equals to a, right? Minus 1 square is positive. So the value of a is 2, and therefore we get the equation as y equals to 2 times x minus 1 whole square plus 1. Clear? So that becomes one of our equations. Okay. Now, I will actually get into details of the vertex form in the next page, standard form in the next page. But here, I'll take opportunity to also write the partial factored form, right? So, I have already given you this equation. Now, in partial factor form, the concept is that we see that these 2 points are image points, right? So what we are given here is a y-intercept and its image. So from here we can write y is equal to x, let's say a times x minus, this image is at 2, right? Minus 2, and the value is 3. Now, if you look carefully at this equation, if I substitute x equals to 0, right, in that case, the first term is 0 and y equals to 3. We get the y-intercept. And if I write x equals to 2, even then, the whole thing is 0 and we get y equals to 3. And clearly, between 0 and 2, we do have this axis of symmetry, right? So it makes sense. We use the axis of symmetry for the vertex form. In this case, we are using the image of the y-intercept to write, correct? So partial factored form is used with y-intercept and its image, right, as shown here. To find the value of a, we can use any one point. So we can use 1 and 1. So if I use 1 and 1, I get 1 equals to a times 1, right? So 1 minus 2 plus 3. And that means 1, bringing 3 on this side, equals to, when you open this, minus a. So we get a as equals to 2. Clear? So we get the equation. And now, when a is 2, we can write this equation as y equals to, let me write here clearly, y equals to 2 times x minus 2 plus 3, right? Right. So that is how we could actually get this equation in the partial factored form. Is that clear to you? Correct? Now let me also share one more thing, which is we found that a is 2 and the finite difference was 4, right? There is a relation which relates finite difference with the leading coefficient a, and that's very important to understand. So a is basically equal to whatever you get your finite difference divided by 2 for a parabola, right? General formula for any polynomial is finite difference over n factorial. So here, a value is half of the finite difference, right? So in our case, finite difference was 4, and if I divide 4 by 2, we get the answer 2. Do you see that? So this is extremely important formula to remember. Now imagine if you knew this formula, right, then in one shot we could have written the equation in both partial factored form and also in the vertex form. We don't have to do this calculation to find a equals to 2, right? We found a equals to 2 in both the cases, which was not really required once you understand that finite difference divided by 2 is the value of a. Perfect? So now we are going to use this particular concept, and I'll provide you the standard form from this data in the next page. So I hope that makes things very clear. Take it as a review of what you had learned about quadratic functions and use the best of information which you get here. So again, we'll work on the same question, and we worked out here that the second difference equals to 4, right? So second difference, I should say second finite difference, equals to 4 in this case. Therefore, it's a parabola. Correct? And now that also gives you, as we just learned, that if I have an equation which is y equals to ax squared plus bx plus c, in that case a will be equals to 4 divided by 2, which is 2. Right? So as shown you earlier, this is a very standard way. A is finite difference divided by 2 for a parabola. Correct? Okay, now that will help us to save some steps when we are writing our equation in standard form. So in this exercise, we are going to write equation in standard form, which is given here, y equals to ax squared plus bx plus c. Clear? So we'll write this equation in standard form. So now a is equals to 2, you can substitute 2 here, and then only 2 parameters you need to find. If you do not want to do that, then you have to consider 3 points, right? So now we know a is 2. So y is equals to 2x squared plus bx plus c, since a is equal to 2, as shown above. Is that clear to you, right? Now there are two variables, we need 2 points. So let points be, you have to choose any 2 points. So 0 and 3 is a very good point to give you, and that gives you the y-intercept. So 0 is the x value, so we get 3 as the y values. Once you substitute 0, we get 0 plus c, right? So that gives you that 3 is equals to c, right? So we get 1, c equals to 3. And now we can use some other point. So we have y equals to 2x squared plus bx and 3. That is the c value. Perfect. Now to find b, we could use some other point. So we use 0 and 3, and we found that c is 3. Right? That is the y-intercept. In this equation, y-intercept is c. Now let us use the point 1 and 1 to get the value of b, right? So let's go move it to the right side. So we can write this as, when I write 1 and 1, so we get, let me change the pen, we get 1 equals to 2 plus b plus 3, so which is 5. So we get 1 minus 5 equals to b, so we have minus 4 equals to b. This is using the point 1, 1. Perfect. And now once we know what b is and what c is, we already know a is 2. We have our equation, which is y equals to 2x squared minus 4x plus 3. So in standard form, that is going to be your equation, right? So I hope the concepts are absolutely clear and you understand how from the data we can actually find the equation of a quadratic function, which when you plot on Cartesian plane looks like a parabola. I hope the concept is absolutely clear. And also remember the formula which we discovered, which is the value of a is finite difference divided by 2. Right. Thanks for your time and all the best.